Okay, so I typed this up for you already, but bless you. If you do have inverse functions, and you compose them, so it's just the notation, that would be f composed with f inverse of x. That will actually be equal to, if you flip that around, f inverse of f of x. So like you guys did like f of g of x and g of f of x, and they wouldn't be the same. If you have inverses, they are actually the same. And if you did that correctly, that would have been question 15 and 16. I just didn't call it that on last night's homework. But if you compose them, they are the same no matter which one goes first, and they simplify to just be an x. So they basically cancel everything out. So what we're going to do an example for is just a quick little proof that these two given functions are inverses of each other. That's all we're doing here. So I know we could switch x and y, solve for y, and all that kind of stuff, but for this, I'm just giving you, here's 3x minus 15 and 1/3 x plus 5. Those are both equations of lines. Those are just inverses of each other. What we're going to do is prove that they're inverses of each other. So to do that, you compose the function with its inverse, then you flip it around, compose the inverse with the function, and show that they both simplify to the x. Now, this is not like a 2-column geometry proof. We don't have to justify steps. We're just going to show algebra, so don't worry about that. But all I'm going to do here, and if you like that other notation better, this would be written as f composed with f inverse of x. And that little notation with the little composition circle, whatever's closer goes first. I like this other notation better, but what this one means, the first one, we're going to plug the inverse into the original everywhere we see an x. All right, so the original is 3x minus 15. So for 3, we'll just write that. Instead of x, use some parentheses here because our inverse has 2 pieces to it, or 2 terms. So 1/3 x plus 5, and I got to multiply that whole thing by 3. The rest of the original function was just to subtract 15. So this is just going to be 2 steps real quick. Full distributive property. 3 times 1/3, those guys are reciprocal, so they just cancel each other out. They would become 1. So it'd just be 1x. Typically you don't put a 1 in front of the x, though. I'm just going to put x. 3 times 5 is 15. And then I have this minus 15 on the end. If I combine like terms there, the 15 and the minus 15 just cancel each other out, and I end up with what I want, which is x. But you do have to show that it works both ways. So if I flip it over, so the next one says f inverse composed with f of x. If you like that other notation, this would be, in parentheses, f inverse composed with f of x, like that. Whatever's closer goes first. So in that situation, that means I'm going to take the original and plug it into the inverse everywhere I see an x. So that inverse, 1/3, and then in place of x, I'm just going to set up some parentheses, take and write down that first function, 3x minus 15. And then on the outside, you just have a plus 5. It's going to be very similar, but the algebra is different. So it should be different steps as you go through here. This time I'm distributing 1/3. So 1/3 times 3, that becomes 1 again, just like it did in the last question. So just be 1x. And if you do 1/3 times negative 15, it's the same thing as negative 15 divided by 3. This is going to be negative 5. And then we have that plus 5 on the end. And now you guys can see it's really similar, but the algebra is actually different, and I have different step here. But the negative 5 and the 5 do cancel each other out, and that also simplifies to be x. So I'm proving that those guys are inverses. If I do the function composed with the inverse, simplify, I get x. If I do the inverse composed with the function, the original, I also get x. So you have to do both sides of that to prove 2 functions are inverses of each other, and we just use composition to do that. Is anybody having a question? Okay, now, these at the bottom, I'm going to use those same 2 functions, and you don't need to rewrite them. I'm just going to rewrite them so you can see them on the screen here real quick. So I have f of x was 3x minus 15, and the inverse was 1/3 x plus 5. So I'm just writing them so you can see them on the screen. We're going to do composition here with numbers. All right, so the first one says f inverse composed with f of 12. So I'm just going to write that other notation with the parentheses. Whichever one you like better is the one I want you to use, but just so you can see both. If you use the little composition circle notation that's in the problem, whatever is closer goes first. If you're in this notation, you're going to work inside out for the parentheses. So whichever one you want to do, you're going to start by plugging 12 into the f of x function. All right, so I just rewrote it so you guys could see it on the screen. When you do these composition problems, it's going to feel like you're doing two problems in one because we're going to have to get a number here and we're going to have to plug that number back in. So the original function is 3x minus 15. So 3 times 12 minus 15 is what I'm doing there. All right, so 3 times 12 is 36 minus 15. That should simplify to give you 21, so we're like halfway there. What you want to do to finish the problem off is you're going to take this 21 and you're going to replace f of 12. Now we know that that's 21. So I do f inverse with the 21 plugged in. And whatever we get here will be our final answer. Now the inverse is 1/3 times our x value, which we're going to put in 21, and then plus 5. Now, if I do 1/3 of 21, that should be 7. I'm going to add 5 to that, and so my answer to the question should be 12. Okay, here's what I want you to notice. In the original problem, I plugged in 12, right? And then we composed a function and its inverse, and the answer was exactly the same as what we started out with. So that should happen, and I'll show you just with one more example. All right, if you compose a function and its inverse, if you know their inverses, they should literally cancel each other out. So if you're asked to plug something in, that should actually be the answer. So I'll just show you with one more. All right, so this one's backwards. So this is the function composed with the inverse. And for this one, we're going to plug in negative 24. So for this one, I'm actually going to start with the inverse. So f inverse, if we plug in negative 24, so I'm using the 1/3 x plus 5. So I'm going to plug in negative 24 everywhere I see an x. Now if you do 1/3 times negative 24, that's going to give you negative 8. Add 5 to that, that would be negative 3. And then this one, now I know what the inverse with the negative 24 plugged in ends up being 3. So what we're going to do to finish off answering the question is plug in negative 3 to the original function. So 3 times negative 3 minus 15, you get negative 9 minus 15, which is negative 24. And again, you're going to notice what I was asked to plug in is what I got. Whenever you compose a function with its inverse, and it doesn't matter which one goes first or second, they cancel each other out through the algebra, and it should just be whatever you plugged in. So if I look at the last question, can anybody tell me the answer without doing the problem? It's A. A. If you understand that, you don't have to go through and do a bunch of work. If you want to prove it, that's fine. But if you understand, hey, I'm composing a function with its inverse and they're going to cancel each other out, I could literally put a picture of an elephant in the parentheses and that would be the answer. Okay, they cancel each other out. So you don't need to do a bunch of work for those problems if you understand that. If you don't understand it, go ahead and go through the algebra and you can prove to yourself that you get out what you plug in if you compose a function with its inverse. Okay, is anybody having a question?